Today we're going to be talking about L'Hopital's rule. So a little overview of what we'll be talking about. So we're going to be showing limits that will end up in indeterminate form, and this is when we're going to decide to apply L'Hopital's rule. Previously, these are the types of limits we've done. So if we have, for example, the limit as x approaches 0 of 2x plus 3 over 4x plus 7, we'll just plug in the 0 on the numerator and the denominator, and we'll end up with 3/7. Pretty simple. This should be what we're familiar with. But what if we had the limit as x approaches 1 of x squared plus 2x minus 3 over x minus 1? We end up with 0 over 0. Now, this 0 over 0, what does this mean? We can't get anything from this. But this is a type of indeterminate form. There's a few of them, one of them being 0 over 0. We also have infinity over infinity, 0 times positive or negative infinity, infinity minus infinity, 1 to the infinity, infinity to 0, and 0 to 0, to the 0. So when we have any of these forms, we want to convert them into one that will look like 0 over 0 or infinity over 0 so that we can apply L'Hopital's rule. So if you have any of these other types, you'll need to rearrange your limit. So now we have L'Hopital's rule. Basically, what it means is that if we have a limit of some function over another function, like the one we previously looked at, what we can do is we can take the derivative of the top and the bottom individually, and then we can evaluate the limit of that function. So, if we go back to our previous example, we could, like you may have done in the past, we could factor it and cancel out the x minus 1, but this function also works with L'Hopital's rule. So what we can do is we'll take the derivative of just the top on its own and then put it in the numerator and then over the derivative of the bottom on its own. So we'll end up with the derivative of the top is 2x plus 2, and then the derivative of the bottom will just be 1. And then we can evaluate this limit from there. So we plug in the 1 and we get 2 plus 2 is 4, so it's 4 over 1, which is just 4. And then if we look at another example, we have the limit as x approaches 0 of sine x over x. If we plug in 0, sine of 0 is going to be 0, so we're going to end up with 0 over 0. This is another indeterminate form. So we want to use L'Hopital's rule again. So if we take the derivative of sine of x, we're going to end up with cosine of x. And then the derivative of x is just going to be 1. So now we have our new limit of cosine x over 1, which when we plug in 0, cosine of x is going to give us just 1. So our limit is going to be 1. And then, if we look at this example, so again, if we plug in infinity, e to the infinity, it's kind of a weird one, but we're going to end up with infinity as that limit. And then x squared, when we plug in infinity, that's also going to be infinity. So this is the other type of indeterminate form that we can evaluate just as is. So we'll end up with infinity over infinity, which means we want to apply L'Hopital's rule. So when we do this, the derivative of e to the x is just e to the x, and then x squared is going to be 2x. So we end up with the limit as x approaches infinity of e to the x over 2x. Now, if we plug in infinity now, e to the x is still infinity, and then 2 times infinity, we're still going to end up with infinity over infinity. This is kind of weird, but we're not actually stuck here. We can just take L'Hopital's rule again. So we'll go back to this function, and then we're going to take the derivative one more time. So we're going to have e to the x is going to become e to the x, and then 2 times x is going to become 2. So this is our new limit we're evaluating. Now, if we plug in infinity, we're going to have infinity over 2, which in the long run, the divided by 2 isn't going to do anything, so we're just going to have infinity. Now we could do this as many times as we needed, but we want to make sure that it's actually going to help. You might end up going in circles where it's not actually helping, but in this case, it's going to help if you take the limit a couple times. So these are the resources if you want to look at them to find out more about L'Hopital's rule.